Hello and welcome. Right now we're going to look at why I think the law of large numbers is the most underrated law in all of mathematics. Right? So, why do I think that? The law of large numbers is applicable in almost any domain, in almost any aspect of your life. Any prediction, any estimation, any metric, it follows this law. What is the law of large numbers in the first place? Let's take a coin toss. It has two faces, a head or a tail, and the probability of either a head or a tail is going to be 50% when you toss it, right? Let's take 10 repetitions of this experiment. You expect 5 tails and 5 heads because 50%. But somehow, you try this a lot, but you're not getting 5 tails and 5 heads. You're getting 4 tails, 6 heads, or 3 tails, 7 heads. Why is that? When you increase the number of repetitions to almost 100,000 tosses, or 10,000 tosses, or 50,000 tosses, the number of heads is almost equal to the number of tails. That is 50%. Almost equal, but never converges. That is due to the law of large numbers. This is a very philosophical concept, I think, because you'd think that we're all unique, right? We have our own intentions, we have our own ideas, we have our own perspectives on things. Yet, when I say that 63% of people are going to buy a coffee today morning from this certain population, it almost always happens. Even though everyone is free will, they're unique. They have their problems, they have their victories. Yet, that's how the law of large numbers dictates us. It fails to look at what every single flaw or every single strength is. Yet, it exactly manages to look at what the entire population averages out to, right? So you might wonder why this happens. So when you have a lower number of repetitions of an experiment, you do not give the experiment time to level out its deviations or average out its deviations. Let's say you have an expected value of 15. In 10 samples, you're not going to get the average 15 because there's going to be a bias. There are going to be people of 16, 17, 18 and such. Yet, when you take the number of samples as 10,000 or 15,000, if there are a number of people getting 16 or 17, there are going to be a similar number of people who are getting 14 and 13 who help to level this average. So then, when the number of samples increases, logically or theoretically, you can say that this average converges to almost 15. This is quite interesting because, like I've said, you don't expect this to happen. But the even more interesting thing is that if I have a population and I have a proper metric, I cannot approach a person and confidently say they're going to do this or they're going to do that. That's because even though the law captures the overall meaning, it forgets individual meaning. So when you can predict the flow of a population, you cannot predict the flow of an individual. And that's why I think the law of large numbers is the most underrated law in all of mathematics. Keep learning. Curiosity is the only reason we've gotten this far. And I'll see you guys in the next one.